Okay, so we have a number of graphs here. We're going to find out where they're increasing and where they're decreasing. And we're going to make a sketch of each one. And what we do for critical points is a lot like we did when we solved inequalities. Do you remember solving inequalities like this? X squared minus 10x plus 21. You found out where it was equal to 0. So you factored it first. And said, I know that it's equal to 0 at 7 and 3. And then what you did is you made a number line, put 3 on there, put 7 on there, because it was greater than. The teacher may have said use an open circle so you remember that those values weren't included. And then you checked values in each of the 3 sections. So when I check a number less than 3, like 0, and I plug that into my equation, I'm going to have negative 7 times negative 3, which is positive 21. Okay? If I was trying to figure out, is that greater than or less than, and usually we had a 0 in there to find out where is the function positive or where is the function negative, then you would put a true or false into that section. So if you were particularly trying to find out where is this function greater than 0, or sorry, the way that I've written it here would be x squared minus 10x minus 21 plus 21. The way this would be read, x squared minus 10x plus 21 is less than 0. So when I plug in a number like 0, is it true? No. So we put a letter false in that section. But if you tried a number between 3 and 7, is it less than 0? Yes. Do you remember doing that in grade 11? A little bit? And then you wrote the solution set from 3 to 7? Yes? Okay. So part of the nice thing about that technique is we use it again with curve sketching, but instead start to look not whether or not it's true or false, but whether something is positive or negative. So here's 2x squared plus x minus 21. If we figure out what the derivative of this is, we will get 4x plus 1. Setting that equal to 0, and solving, move the 1 over, divide by 4. We will get x equals negative 1/4. That's going to be a stationary point. If we put that stationary point on a number line, and we think about values before that and values after that. If I choose a number less than negative 1/4, say negative 10, and I plug that into my derivative, if I plug in negative 10 for x, can you see that I'm going to get a negative answer? And if I have a derivative being negative, that means it has to be decreasing. Now I hope that you already see from the original equation that this makes a parabola, that you already know that a parabola with a positive number in front looks like this. Okay? But this helps us see where the calculus is going to come into play. So we're going to find our critical point. This negative 1/4 is going to tell us our vertex. If we plug in negative 1/4 into our original function and solve for it, we'll find out exactly what this vertex will be. I'll let someone do that on their calculator for me to figure that out. We see that before negative 1/4, since our derivatives are all negative, that our function must be decreasing, which we can see in the graph. After negative 1/4, if we plug in a number like 5 and plug that into our derivative, 4 times 5 plus 1, 21 is a positive number. That'll mean that our function is increasing after that. So the way that we'll be able to graph our function is we'll start with our minimum value, which is negative 1/4. Has someone figured out the y value? Sorry? Minus 169 over 8? You think so? Okay. Which would be minus 21 and 1/8, or minus 21.125. Is that right as a decimal? So what? You would get this blue number by plugging in negative 1/4 for each of the x's in your original function, because that would be a point on our original graph. And then since you know this is now a minimum, and this little diagram right here really helps us see that it is a minimum, because the only way it can be going down and switch directions and go up is if it is a minimum at that point. You can get this basic shape right away. And since you know what an x squared graph looks like, you also kind of know how it curves and stuff like that. Yes?
But then I would have more stationary points. I would just take a point between two stationary points and find out whether what points may be maximum.
Yeah. If you have more than one stationary point, these arrows would tell you which way that it goes. So I'd like you to try the next one. It's another parabola.